Hi everybody, welcome back to this new episode for the STM32F1 tutorial, and we are working on the I2C communication. In the previous episode we created a function that established an I2C communication with a device, but nothing better to have a practical example to understand how we can program an I2C device. So for this time we are using the OLED display or the SSD1306 to have an example on how we can write data on an I2C device. So by the end of this video, you will be able to control and set up the OLED screen. You can be also displaying a message in the X and Y desired position. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. So, as usual, we can find the code that we will write together in GitHub. The link is in the description below. The language that will be used is C, and the program that we are going to use for writing the code, loading and debugging is the Kale version 5. Finally, as we are going to use some previous libraries, the level that is required for this video is intermediate. So the hardware that we are going to use is the STM32F1 or aka Blue Pill, and the OLED screen, the SSD1306. Okay, so within this tutorial, first of all, we are going to introduce the OLED screen, have a little bit about an idea about the features. Then we are understanding the addresses and the type for this OLED screen. After that, we are going to take a look on the I2C communication. Then we are going to start making the code. First of all, we are going to create the comment function. Then, using the comment function, we are going to create the OLED init or the initialization function for the OLED screen. After that, we are going to go and code the OLED data, and this is the function that will go to write or show actually will display on the OLED screen. Then we are going to display hello WeeW. Finally, there is a small bonus for this video. So let's take a look on the OLED screen. So the OLED screen is first of all a single chip CMOS driver with a controller. So there's a controller that is called the SSD1306 plus a dot matrix display system. Also, it consists of 128 segment and 64 command. So we will take a look later on the how this is going from display perspective. Finally, this is also a pin selectable MCU interface. So this means that you can find some of the same OLED display with this chip, the SSD1306 with a 8-bit 6800 or 8080 series. You can find also an SPI interface with this one too, and also an I2C interface. Finally, it has directly an internal on-chip oscillator. From the communication perspective, what you have to connect is the microcontroller, and then you do have the SDA and the SCL, then also the powering 3.3 volt and the ground. So you can take a look on the graph here how to power the I2C configuration for the OLED screen. And the address is the hexadecimal 78. Okay, so let's take a look now on how this display works. Same if you have seen also our previous episode for the Nyoka display, the logic is almost same. So for this SSD1306, it's composed of pages, and each page, so for this model, especially this model, the pages are from 0 to 7, and so it means we do have 8 segments that we are going to use, and each of the pages or rows there is 128 segments, and each one of them have a one LED display. So in total is 128 by 64. Okay, then let's take a look on the addresses and type. So we went to this function, so let me show you here first. This is the back of the display, and you can see the hexadecimal 78. And so if you can take a look, so this is the model where we do have 128 by 64 display bits, and also the display is related to this resistor here, the soldered resistor. So usually this comes with this configuration. However, you can use another secondary address, which is the hexadecimal 70A, and this is by unsoldering the previous one and solder within the yellow arrow. So you have to change this one manually so you can get the different address. Let me go back quickly on this one. This is a model I bought from Amazon, so I would call it the Amazon model. And this model that I bought from AliExpress, so I would call it the AliExpress. As you can see, the back is different. However, so it's also a 128 by 64 display. However, the address, the primary address, is totally same, and also the pin connection is also same. But to unsolder, you have to unsolder the other one and put the solder on the yellow one. So the secondary address is available only if you change the soldering. Good, and finally, let me share with you the third one. This third one is 128 by 32 display bit, so it's a half of the other one that we shared before, and also it has only a primary address. There's no way to change the address to have a secondary. So now we finish our review, we can take a look on the I2C communication. So for the I2C communication perspective, what we can take a look. So as we have seen in the previous one, we have to first send an address, and then after sending an address, we have to send each time a control byte. The control byte determines if we are going to send after that byte a data address or a control address. So if we go like that, so this is the I2C bus data communication. So we can put the control byte from control byte perspective. If the control byte is a 00, means we are sending a command. So every data coming after this control byte will be a command data. And if the control byte is a hexadecimal 40, then we are going to send a data address or a data command, sorry. Okay, so now that we know how to do that, let's start and create the OLED command function. So we are starting back from the project that we finished in the previous tutorial where we created the I2C communication function. So, but this time I added the C file for OLED drive and the header for the OLED drive too. And for the C file, we are starting to create the OLED command at 1 byte and the OLED command 2 byte. So for this one, so we can really simply just copy this one, the function we created in the previous tutorial, and make some changes. So the first one is so here. So we do have this one that we don't exist because we need to copy paste them in the header file. So let's add them in the header. So I2C, let's start by the first one. This one here, and also this one too here, and finally this data and stop that we have to add so that we can use them in the OLED drive file. Okay, and we should be good then. Okay, that's perfect. So we should now, if I save here, so this one should be accepted. Great. So for the address, so let's change this one a little bit and we call it the OLED like this. Okay, the OLED command. So in this one, so we still need to confirm which I2C to use, but the address, we don't need it anymore because we know the address that we would like to use. And here we are going to input it directly. And it's the hexadecimal 78. And for the data will be, this is only 1 byte, so it's not anymore an array, but just one char. And here, so what we are going to use, instead of having this one, so as we said, this is a command function. So first of all, so we are putting data here, but before sending the data, we have to say that this is a command. So, and this one, if I put I2C and I'm sending the 0x00, this is what says sending a command. Okay, and I think that's also I'll put here. This is control function for a command. Okay, and here just a command saying the 078 is the primary address. Okay, good. So this is the first function, and the second one is quite really similar and simple. I think some simplification can happen, but we can review it later. And here, instead of data, we put data like this. So we will have an error here, and what we will put for I, so we will add here I less, for I equal to 0, I less than 2, I plus plus. We just put this function here, and this will be data of I. We will see in the next part of this tutorial why we will need this function for some setup. Okay, I think we do have this one, so we just remove this I as we don't need it anymore here, and we do have our command function ready to be used for the initialization. So now that we have completed the OLED command 1 byte and OLED command 2 byte functions, we can go jump and start the initialization of the screen. So before jumping and starting directly coding, let's take a look to the datasheet of this SSD1306 and have an idea about how this dotted matrix is working. So this is the datasheet. And so it's a quite not a very big one. It's 65, and I quite advise you for reading it. It's a very interesting one where you can learn how this driver work with the display. Most of the data, there is a lot of technical things that you may read, but you don't really have any how to say, this is really to customize to a certain extent this this device. But actually there is some important part that I would advise you to focus. So the first one is about the I2C, where you have here the functioning of the I2C and how the command is working. Then you will have here how the signal is working for the I2C, and finally how the communication and the details are working here. So you may take a look at this. It's quite interesting, so you will understand more fundamentally how the communication works with this device. Then the next part where I advise you really to take a look is the part where you start having a review for the command table. The command table, so this is for the command where you control the data. And for example here, so if the A4, so if you send first the control command of 00 hexadecimal and then A4, your display will be off. But if you put the 00 hexadecimal plus and then you send the hexadecimal A5, your display will show will be on. So this is the same. So the first one, this is really a fundamental command, and then some scrolling activity which are not covered within this tutorial. But after that there is the addressing, which is a very important one, and this addressing is the one that help you to control the position of your data when you send it later on with the comment for the data. Finally, this is the hardware configuration, and we are going to go through this one right now to make the initialization. Okay, so to be honest with you, it's a bit tough to work on initializing this display, but fortunately at the end of this document, if you go really at the end, you will see, not this one, it was the previous day, yeah, almost the page 64. So you can find the steps to initiate your device. So actually for the device that I shared with you previously in the slides, we need to make some change, and we are going to go through that together to make it. So first of all, let me make a smaller one for this one so we can see both of them, and we can see how we can use this to command. So let's first create this one. Okay, let's create void and put here, and we will need only the char I2C to start this one. Okay, so let's begin our initialization. So first of all, we can copy or cut this function because this is something that will be integrated directly here, and we will start using our first command. So the first one that we are going to use, we need to add 2 bits. So let's put a char, I will call it command, and that will be equal. So here the hexadecimal A8 and 3F. Okay, so we need to put here as a hexadecimal. Okay, so what we can do later, yeah, let me add this one here. Okay, and what's happening here? So it says, yeah, of course, because I need to put no, actually it looks, yeah, I need to put this one as an array. It should be fine now. Perfect. After that, let's open this one, and what we put here, we put the I2C. So we can put it at the fast mode, and this one I2C here will be I2C here. So here I2C and command. We should this function should work properly. So the first one is normally, as they said, no need to change for this one. Then the next one, so we just copy here, so we can copy this one directly again, and instead of A8, so here 8 will be let's put it command 1, and this one will be D3, and after the D3 we will have to send a 0 0. Okay, so let's go to, this is command 1, let's go to the next one, and for command 2 we are going to go for this one. So we don't need 2 byte, it will be a 1 byte command, and instead of I2C, so I don't need command 2 for the moment here. So this one is to display start, we need to put 40H, so we just put a hexadecimal 40. Okay, and after that we can go to the next one where we need to put the A0 A1. So actually what we can do for this one, we are going to put A1, and this is a setup. So for the segment remap, for our configuration, we need to put the A1. Okay, so we just put a copy here, and we paste, and we put here for the remap, we need the hexadecimal number A1. After that, so you can see it's quite straightforward. As soon as we create all the formula and everything is ready, so there's no issue at all, and we can jump quickly on it. So here we put the C0. So we do have the C0, and here we put, so we have to choose, actually it's wrong again. Apologies. Yeah, for the I2C we need 1 byte for this one, and between C0 and C8 we have to choose C8. Okay, so if you would like to know what is the meaning of this one, you can go back to the command table to see all the different behavior and which one. So for this one we need to put it as a C8. After that, yeah, here we need a command, a new array. Okay, so for this one will be command 2, and this is a hexadecimal number of DA, and the point is we are going to put for the DA, instead of 02, for this one it's very important, we have to put 12. Okay, this is a very important one for this display, for the special display that we do have here. Okay, so after that we are going to make another command 3. Okay, so command 3 here, and the command 3 is 81, and for the 81 we are putting 7F, hexadecimal of course. Okay, and this is to set up the contrast. So we put here a 3, And after that, so we can add the other function A4, so we display on. Okay, we put here display on, and it's an A4. Okay, after that A6, so we are going to have a normal display. A6. Okay, and we will need to add another command array like this. So we call this one 4, and what we are going to, so it's D5, the hexadecimal D5, and for the D5 we are going to put the hexadecimal 80. Okay, so let's save here, and finally we have another final array to use. So for this one, the command 5, and okay, so this one should be 4 to not make any mistake, and for the for this one is 8D, and for the 80 we are going to send the 14 hexadecimal. Okay, and we just end up everything by putting here, by displaying on and putting AF to at the end. So by putting all of this one, we create the display on. However, there is one small change that we need to add, is about the addressing mode. The addressing mode, we are going to use it so we can have, let me show you the addressing mode. We are going to use, let me go quickly here. Yeah, like this one, in a way that we can go like this and come back each time. This is the addressing mode that we need to set up. It's not set in the startup one, but we need to have it right now, so we can easily control the display later on. So what we are going to do is to have the command 6, where this one is 5. So normally, let's check again. So we do have the command, yeah, everything looks fine. So let's go back here, and there is another command that we need to add, and it's quite very important. So let's check them. This one is here, perfect. Okay, so let's add the command. This one will be 6. Let's copy, just copy. Let's go back again and just in case confirm that we put it everything. So T30, perfect. And then we have the C0. This one, no. This one AH12, the AH12, so command 1. Command, this one should be, this is command 2, perfect. Okay, looks so far so good. So let's add display 1, how we would like to have the display. This is normally by default, but just in case. Okay, and to set up how we would like to display, we need to put 2 0 and 1 0. Okay, good. And for this one, we just add command 6. So let's change this one to command 5, 4. That's correct, and we should be good here. Okay, so let's add this one here and copy this function in the header. Let's add here, and then an extra line. We just have to copy then this one to be, we don't need any more this data, and we don't need to use this both two because this is not within our example anymore. So let's save here, let's go here, save and build. Okay, there's full warning, probably end of line to be save here. Okay, here looks good, here looks good. Let's save, build again. Okay, so there's no issue, no error. So I prepared the setup here. So this is our screen, and this is our STM32F1. So if we run this, okay, nothing happened, of course, because I didn't initialize in my main program. So after the sysdig, let's copy. So I'm connecting right now with the I2C2. So I put here 2. It should, no, it's not letting it. Ah, yeah, OLED in it. Yeah, it's interesting. Okay, so we do have this kind of a strange picture, but we are having a good start, because now we can see that our screen is showing something. So we have successfully initialized the screen, and so now we can start really writing the data and displaying it. So let's jump and making the first step of OLED data, or the function that will help us to display the data on the screen. Okay, so let's go back to our file for the OLED drive and start with the OLED data. I guess you already understand that it will be quite a very simple exercise for the OLED data, because it will be exactly same as the command function. So let me copy this one, and instead of command I will put OLED data. So if I put here, and let's put here, and okay, chart data and I2C. And the difference here, when the control function here for a command, I need to change it as 40 hexadecimal, and this is a 4 data. And as you can see, it's quite very simple and easy. Then, so after doing this data, there's two other interesting function. One other will be using the command function, and this is about the position in the screen. So this is the command that we will create now to have easy control from where we would like to start. And if we go back quickly, so if we go back quickly to the datasheet, so just for you to have an idea about this, how this is working, so you don't get lost. If I go here, let me check it, where is it? And not here, and should be not here too, so that should be a little bit later on. Not here. Yeah, I think this is the one. Set page, not this one. I think the one starting with yeah, this is the one. So here, for this one, if we put a command and then we add, so just a moment, for if we add this one, so this to 1, as we do have 128 position, so it's an FF1, so it's a 4F, sorry, it's a 2-byte a function. So we need to send, so the first, this one is a lower F, when this one is the higher F. So when we will put it, we need to be sure that we are putting the right one. So you will see, and I get it later on. So for this function, so it will be a void, and we call it OLED pos, where we have to add the char for the Y position and also the char for the X position. Okay, good. So to set up the X position, because it's the easier one, so we will need OLED 1 byte here. And yeah, I forgot to add again the char for I2C, so which I2C we are going to use, like this. And so we are putting here I2C, and what we are going to send for the first one, so for the first one we need to send the first function of 00, so the hexadecimal 00 plus, and here what we are going to put is 0, and then we are putting n, so let's put the hexadecimal 0f just in case, and the expos. Okay, so we are going to take only the first byte of my expos. After that, so let's add this one here, and then what I'm going to do, so it will not be a 0 0 but 1 0, and exactly the same logic here, but I need to switch this one by 4, and if I put this one like this, I'm sending the next byte. So like this, we are putting the X position. To add the Y position, let me go back. So where is the command for the, this is a scrolling, and let me check, where is it? Yeah, exactly. So this B0 to B1 is the page or the row that we would like to select. So we just send exactly same like this one, but it will be here not a 0 0, but it will be a B0 plus my Y pos, and that's all. Here we do have my position decided where I would like to start. Quite very simple and very easy to do. So now we can control where's the position of the text I need. Okay, so here we are with the end function. This is the function that will help us to make our screen blank. Let's put this one like this, and I will not forget to put the I2C, as we need to select each time the I2C. So what we are going to do first of all is to select my position. So we are starting directly from the position 0 0. That's where I will start cleaning my my screen. Let's remove this one. So this one will be 0, and this one also will be 0. Where, let me remove this, where this one like this. So now I'm starting at the position 0 0. Let's put int here, int I and j as two variable that I'm going to use, and what I'm going to do is just going to clean and sending the data. So what I'm going to do is for I, and so I equal to 0, I less, so I equal to 0 and I less than 128, I plus plus. So actually for this one it's not 28 but 8. We are going row by row. So I plus plus like this, and then for I again, so we put not I but j here. So j, and j we put here. And what we can do is to put here, and we put the we can use the data one like this, and we are going to send a 0. Okay, just in case. So this one is I2C, where the data I'm going to send is a pure 0 that we are going to send. And that's all. So this is what we are going to do, just in case we put at the end that we are going back to the position number 0, so we are sure that when we start writing from the beginning, we should have should start from the one number 0. Okay, so now we are really good, and we can start cleaning our screen. So let's copy paste this one and put it here. Okay, so let's copy it again. Go here. So I will create a small delay function. Delay ms. That's interesting. Delay ms of 2000 millisecond. And adding this one, I2C, it will be 2. Good, so let's save and build just to see if there's no error, no problem. So let's take a look now, go back to our small screen. So we're still back to this strange screen that we do have here. So let's run, save, and load. Okay, we wait a little bit. Okay, so we do what we had happen here is a part of the screen has been cleaned, but not all of it. So something strange did happen. Let's go back here and try to understand what's going on. Of course, because we have not been putting here 128, save, run, and if we run it now, we should wait a little bit and have our screen totally cleaned. So after that, we are going to start writing something. So we just finished the OLED data and we have the core function to print on the display. So we can jump now and display our hello WeeW. Okay, so for this part we will need a small extra thing that I added directly in the header library, and this is the static const char ASCII2. So you just have to write it on the on Google and you will get this one. This is the same that I used to create the digits in the LCD for the Nokia LCD example. So it's exactly the same, and this is a very useful array that you can use to write a digit. Okay, so let's start. Let's start with the first one, the void LED print. So void OLED print. This is the one that will print using the array that we have added to the OLED drive header. So let's put it here and start to write what we want. So it's exactly the same as the one for the LCD, Nokia LCD. So we need two variable a, I, and j, and after that what we have to do, so while, yeah, and also I have a string to print. So if I put here, no, char, and I will call it str. Okay, so we will put I equal to 0. Okay, and so while str of I, okay, so still we do have something to print. We have to do this. So for each time j equals 0, j less than, yeah, where is less, yeah, less than 5, like this, sorry, and j plus plus. So now we will go through this array. So each time, so it's not an array, actually it's a matrix. It's a matrix. Okay, and what we need to do is just sending. So let's go and we take the OLED data here, and we are going to take this one here. So we are going to use the I2C that selected, and here it's not data, but it will be str of I. Let's put it correctly, so it will be ASCII the str, so here, and we put the str of I minus 32 to get the right number. So I have to put here, let me check, so let's put this one between parentheses like this, and this one will be j at the end. So let's put here, this is the number, and when selecting this one we are going to print. So let's, this one is here, so this one is inside, and here I have to put j. Okay, that should be all. So let's save. We need to put this function on the header side. Let's put it here, and let's go to the end. We may need to add an extra line. I think the line is there, so we are good. So let's copy this function and go here and write. So we are going to use I2C2, and my string will be, we are going to send the hello wheel. Oh, well, okay, that should be nice, but there's something saying that is wrong. LED, I always forget to add the OLED. Okay, let's save and build. No error, no warning. So let's load in the microcontroller and see, check. So there's a 2-second, and then it starts writing and writing. Something goes not correct, so let's check. Okay, so something is not sending properly. Probably there is an infinite loop here. Yeah, of course. So this is not working because I have to put I++. Let's save, run, and load. Check. And we do have our nice hello view. That's really fantastic, but still I would like to control the position. So we already created the position of where I would like to start. So let's make this one bigger to have this function quite easily. So let's go here and create the function that we would like to create. So this is, let's copy this one and put like this. Instead of that, we are putting OLED message instead of print, and not also the string, but we would like to add the position, so where I would like to add my my string and everything. So let's put it here. Okay, so I will put this one like this, and it will be, so it will be, I will need first, so let me copy this one. Yeah, something is wrong here, I need to check. Yeah, this is an extra, and this one should be like this. For the str, I'm removing this str here and removing the char, and then I'm moving this I2C. But before that, we need to add the OLED pos, where we are going to add, so if I put here I2C, y pos and x pos, we do have a really nice function that control everything. And you see, when you create a code that have this kind of modularity, it becomes at the end very simple to build whatever the function, even it is quite very rich in functionalities. So let's take this one here, and instead of putting this one, so let's change this one. So I put message, and I would like to put it in the row number 3 and in the position number 20. So let's check, it should be here, correct. Okay, no error, no warning. So let's make this one smaller and load the code. This one should be deleted, and you can see we do have a hello view in a different position. Let's remove the delay because it's we don't need it anymore. We are sure that it's working. So I'm saying this is not really in the middle. So if I add another 10, just in case, I put 30, save and load. Just a moment, build and load. You can see that I moved a little bit. So my message function that show a hello view is working properly. Okay, so we are going to use the same code as we used before, but the only change is we are adding both here the OLED display. The first one, which is the 128 by 32, is connected to the IC2 number 2, and the 128 by 64 is connected to the I2C number 1. So now we are activating only the I2C2, and if we run, so let's build just in case and load, we will find that nothing is shown in this screen. So if we go and we make a small change in the init function, so if we go to the init function and change this one to 2, and if we run, build and load, you can see that now we do have the same behavior that we needed as the same screen. So let's optimize this code. So instead of here, let's put here another char that we call it screen size. Okay, and what we can do then, so let's put this one, copy it and add it here, so for the init. Okay, and after that, so this is what we are going to do is the init, we are going to copy the init here, and let's change it a little bit. So for the init here we call the 64, and so what we put here is the screen size. We don't even need the screen size, but what we are going to do is putting like this. So the 64 and here screen size will be written here. Okay, so the 64 is, let me copy and take this one. So if we are going to use the 64, then we are going to put the hexadecimal number 0x20. And if we are going to use the 32, let's put here the 32, and we are going to put here the hexadecimal number 22. So let's take these both functions to here to add them. So let's put, so this init, I think this one can be removed, and I can put this one here, and also adding this one. Okay, so let's go here and put the OLED init for the 64. This one is actually the 32, and for the 64, let me put it here, and here will be a 64, and this one will be equal to 1. So I can just copy this one here and go put 1 and 1, and let's see what kind of result we will have. So no error, no warning. Let's put this one here. I think for the small one, I would like to put it in row number 2, just in case. And let's, okay, so we do have here in both, there's a small mistake happening. So if I go, you see the hello WeeW is a little bit bigger than the other one, and this is because, let me check, so 64 is connected to 1, and let's check the 64. The 64 is 02, which is correct. Okay, something, okay, screen size, we are putting 02, correct. Let's check again by load. Probably, oh, okay, I understand where's the issue. I think the for OLED blank here, this is a function that I need to put here for the OLED blank. Yeah, it was correct here too. So 3, 2, 1. That has been working properly. So why this one is not working? Oh, I know, because for this one, let me change. So for this one, if we go here, where is it? So both are I2C. This one is 002, and that's what we needed. Screen size going here, and 02, 012. Let's change this one, just 12 to check what's happening. Okay. Okay, perfect. It was 12, not 02. My bad, my mistake. So now we can control both of them and having the right display as we need. Okay, if you followed until here, thank you so much. Really appreciate your support for this channel. Thank you so much. Please subscribe and put a like if you enjoy this kind of video. Thank you so much. WeeW!